There is a line beyond which the word exit simply ceases to exist. It is the event horizon rule. We are investigating nature's perfect crime, a trap with no walls and no bars, where space itself falls into the abyss faster than light can fly. It is useless to fight here. This is the place where your tomorrow gets forcibly replaced with never. If we believe science fiction movies, a black hole is the loudest thing in the universe. They show us an insatiable monster, a cosmic hurricane that prowls the galaxy, sucking in planets, stars, and light like a giant industrial vacuum cleaner. We are used to seeing it as a funnel, a vortex going down into the underworld, accompanied by the roar of tearing matter. It is the embodiment of chaos, fury, and destruction. But reality is far more terrifying, and it is absolutely silent. Forget everything you have seen in the movies for a minute. If you flew up to a real black hole on a spaceship, shut off the engines, and just looked out the window, you would not see a hole in the floor. In space, there is no floor. There is no up or down. You will see a sphere. It is a perfectly round, absolutely black object hanging in the void. It does not look like a gap. It looks like a physical body. Imagine the blackest paint imaginable, formed into a flawless ball. It looks like a drop of ink frozen inside a crystal glass of water, or a black sun cut out of the fabric of reality with scissors. It is motionless. It is silent. And against the background of burning stars, this blackness seems unnatural, something that should not be here. To understand what we are dealing with, we need a new scale of measurement. Earthly kilometers are meaningless here. The human brain handles such numbers poorly. So let us try to weigh this darkness. Take, for example, the behemoth living in the heart of the galaxy M87. Astronomers call it a supermassive black hole, but the word supermassive is too weak. Its mass is 6.5 billion suns, 6.5 billion of our stars, compressed into a single point. If we took this monster and gently placed it in the center of our solar system instead of the sun, it would not just take its place. Its shadow, its horizon, would consume Mercury, Venus, Earth, Mars, Jupiter. The boundary of this darkness would stretch far beyond the orbit of Pluto. It is an abyss, the size of an entire star system, and this shadow possesses gravity of such monstrous power that it can hold an entire galaxy on a leash, forcing trillions of stars to orbit around it like moths around a lantern. And here we come to the main misconception of humanity, to a myth that prevents us from understanding the true nature of this trap. We are conditioned to think that the gravity of a black hole sucks. The very phrase, black hole, makes us think of a drain in a bathtub. We imagine an invisible pump pulling us to our doom, but there is no air in space, and there cannot be any suction. A black hole does not work like a vacuum cleaner. Imagine a mad experiment. What if right now, in this very second, our sun disappears, collapses, and turns into a black hole of exactly the same mass? Would it be the end of the world? Certainly. 8 minutes later, the sky would turn black, plants would stop receiving light, and Earth would begin to freeze. But would the thing we fear most happen? Would we be sucked into the funnel? No. From the perspective of gravity, nothing would change. Earth would not deviate from its orbit by a single inch. We would not feel any jerk. We would simply continue to fly through eternal night, in the same circle, year after year, million years after million. We would orbit around a dead black point just as we orbited around a living hot ball. Because a black hole does not want to eat you. It is absolutely indifferent to your presence. It is not a hunter chasing prey. It is a trap. It waits patiently. You can circle around it forever. Safe as a satellite, you can build a space station in its orbit and watch how starlight distorts around its equator, creating bizarre halos. Gravity will not kill you as long as you keep your distance. But its danger is not in the force of attraction. Its danger is in the geometry. This is the only object in the universe that has an edge. If you make one wrong move, if you slow down just a little and cross the invisible line known as the point of no return, the trap will snap shut. But it will not slam like a prison cell door. The exit will not disappear. The very direction back will disappear. You will not feel a blow. You will not crash into a wall. You will simply find yourself in a place where space flows down faster than you can climb. And to understand how this is possible, we have to forget high school physics. We have to forget Newton and look at the universe through the eyes of the man who first guessed that gravity is not a force at all. It is a road from which you cannot turn away. To understand how the perfect trap works, we first need to understand what it is made of, and this is where our intuition plays a cruel joke on us. When you drop a coffee cup and it flies to the floor, what do you think? You think the earth pulled it down. We imagine gravity as an invisible rope tied to every object. We picture it as a magnet hidden deep within the planet, actively grabbing things and dragging them down. This is what we were taught in school. This is what Isaac Newton wrote. Newton gave us beautiful formulas. They allowed us to build bridges, launch satellites, and even land on the moon. But Newton's theory had one problem. He knew how gravity worked, but he had no idea why it worked. If the sun disappeared, Earth would fly off its orbit instantly. But how would Earth know? How could the emptiness between them transmit a signal? Newton called this action at a distance, and it drove him mad. He realized a major piece of the puzzle was missing from his picture of the world. There are no ropes. There are no magnets. 200 years passed before a humble patent clerk named Albert Einstein offered an answer that turned our understanding of reality upside down. He said, "Gravity is not a force. Gravity is a shape." That sounds strange. How can emptiness have a shape? We are used to perceiving space as an empty stage where the action takes place. Actors come out, play their roles, and leave. But the stage remains unchanged. It is flat, rigid, and indifferent. But Einstein saw that this is not true. Space is not an empty box. It is a fabric. It is a flexible, dynamic structure that reacts to matter. Imagine a tightly stretched trampoline. If you place a heavy bowling ball in the center, the fabric sags. It creates a depression around itself, a pit. Now, if you take a small ping pong ball and roll it along the edge of the trampoline, what happens? It won't fly in a straight line. It will start describing circles around the bowling ball. Ask yourself, does the bowling ball pull the small ball toward itself? Is there an invisible thread between them? No. The small ball is completely free. It is honestly trying to roll straight, but the very surface it moves on is curved. Geometry dictates its path. It falls into the pit created by the mass. This is gravity. The sun does not pull the Earth. The sun, with its colossal mass, bends space around itself, creating a giant gravitational valley, and Earth simply rolls along the slope of this valley. We are not prisoners of a force of attraction. We are prisoners of geometry. But a trampoline is just a two-dimensional picture for our convenience. In reality, things are much more complicated because we live in a three-dimensional world, and this is where our brain starts to stall. It is easy for us to imagine a curved sheet of paper, but how do you imagine a curved empty room? Let's try to shrink down. Imagine you are a tiny ant. You live on the surface of a huge red apple. Your world is the skin of this apple. To you, a small creature, this world seems flat. You look ahead and see the horizon. You start to crawl. You crawl, as it seems to you, in a perfectly straight line. You do not turn anywhere. You move your legs one after another, strictly forward. You do not feel any turn. But if I, an outside observer, look at you from the side, I will see that your path is an arc. You are describing a circle around the apple. Why do your senses deceive you? Because you are inside the curvature, you follow the surface. The same thing happens in space. Only instead of an apple, we have space-time itself. Any object with mass, a planet, a star, or you yourself curves the space around it. And here appears the most amazing rule of this new physics, a rule that explains why a black hole becomes a trap. This rule is called the geodesic line. In a curved world, straight lines do not exist. The shortest distance between 2 points is always a curve. Light, planets, and falling apples, they all simply follow these natural lines of the landscape. They slide along the gutters laid in the fabric of the universe. But if gravity is not a force, why do we feel it? Right now, you are sitting in a chair or standing on the floor. You feel the weight of your body. You feel the floor pressing against your soles. It seems to you that gravity is pulling you down, but Einstein would tell you, you are mistaken. It is not gravity pulling you down, it is the floor pushing you up. This was perhaps the happiest moment in Einstein's life. A thought experiment that put everything in its place. Imagine a person in an elevator. The elevator cable snaps. The cabin starts to fall into the shaft. What does the person inside feel? He feels weightlessness. If he takes keys out of his pocket and releases them, they will not fall to the floor. They will hang in the air, right next to his eyes. If he pushes off the wall, he will fly to the other wall like an astronaut in orbit. In this second of falling, gravity has disappeared for him, switched off. Why? After all, the Earth is still below. The mass of the planet has not gone anywhere. Einstein's answer was shocking. The person in the falling elevator does not feel gravity because he is finally moving naturally. He is moving along that very geodesic line. He is sliding through curved space. Nothing is hindering him. In our usual understanding, to fall means to lose control. But in the world of general relativity, to fall means to be free. When you stand on the ground, you are actually resisting the universe. The floor, the walls, the chair, they prevent you from moving along your natural path to the center of the Earth. The gravity you feel is not the pull of the planet. It is the resistance of matter that does not let you fall. This is a key moment for understanding a black hole. Falling is the most natural state in the universe. Planets fall around stars. Stars fall around the centers of galaxies. It is free flight, and that is exactly why a black hole is so insidious. When you approach it, you do not feel tentacles grabbing your ship. There is no shaking, no grinding, no pressure from G-forces. If you close your eyes, you will feel, just as you would in deep space, in complete, absolute weightlessness. The space around you begins to bend more and more. The slide gets steeper. The fabric of reality twists into a funnel, but for you, the falling observer, everything looks normal. Your local straight line now leads directly into the monster's maw, but you feel as if you are floating down a quiet river. You, like that ant on the apple, continue to crawl straight. You do not feel that the surface beneath you is no longer an apple, but an endless funnel. Geometry becomes a trap, precisely because it is invisible to the victim. You are not fighting a force. You are simply following the path the universe has laid for you. But every slope has a limit. Every geometry has inflection point. And the closer you fly to the black sphere, the stranger this slope becomes. In ordinary life, if you ski down a mountain, the slope might be steep, but it always leads somewhere forward. You can turn your skis and brake. You can change your trajectory, but near a black hole, the curvature of space reaches such extreme values that the very concepts of forward, backward, and sideways begin to melt. The fabric of space does not just sag, it begins to flow. And here we come to the very line for which we started this journey. We are approaching the place where geometry goes mad. So you are falling. You feel weightlessness. It seems like you are simply floating in the void. But if gravity is just geometry, just a pit in space, why can you not climb out of it? After all, we know that if you roll down a ravine on a bicycle, you can gain speed and drive out the other side. If you fall into a pit, you can throw a rope and climb out. Why does a black hole violate this rule? Why is it a pit with no slope upward? To understand this, we need to stop thinking of space as a frozen stage. We must imagine it as something alive, as something that can move. Imagine a river, a wide, calm river that flows slowly toward a huge waterfall. You are a swimmer in this river. The water is space. The banks are the distant universe. While you are far from the waterfall, the current is very weak. You can easily swim against it. If you paddle at 5 miles per hour, and the river flows at 1 mile per hour, you win. You move upstream, away from danger. You control your fate, but the closer you get to the edge, the faster the current becomes. The river narrows, the water accelerates, and then comes the moment when the speed of the current equals your speed. You paddle with all your might. Your muscles burn. You squeeze out everything you are capable of. But to an observer on the shore, you are standing still. You are paddling at 5 miles per hour, and the river carries you back at exactly the same speed. You are in equilibrium, but it is a terrifying equilibrium, because if you get tired, if you slow down for even a fraction of a second, you have lost. In the world of astrophysics, the role of this swimmer is played by light. Light is the fastest swimmer in the universe. Nothing can move faster. It is the absolute speed limit, 300,000 kilometers per second. It is a law written on the foundation of creation. Einstein proved that to outrun light, you need infinite energy, which does not exist in the entire universe. Now imagine that the gravity of a black hole does to space what the waterfall does to the river. It forces space itself to flow inward. It falls into the center of the hole like water down a drain. The closer you are to the black hole, the faster space rushes past you, heading into the darkness. Far from the hole, this speed is negligible, but as you approach, it grows, and at a certain distance from the center, a critical moment arrives, the moment when space begins to fall inward at the speed of light. This invisible line is the event horizon. Think about what this means. Imagine you are exactly on this line. You turn your spaceship with its nozzles facing the black hole. You turn on the engines to full power. You accelerate to the speed of light, the theoretical maximum. You try to fly away, but the space beneath you, the very vacuum through which you fly, is rushing backward into the darkness at the same speed, the speed of light. You fly forward with all your strength, but you remain in place. You are running on a treadmill that is moving at the ultimate speed of the universe. Step forward, step back, zero. This is the boundary, and it is the point where physics puts you in checkmate. But what happens if you cross this line? What if you take one more step inside? There, beyond the horizon, the river of space accelerates even more. Now it flows faster than light. Even if you turn into a pure beam of photons, even if you become light, you will still move backward, because the medium in which you exist falls into the abyss faster than you are capable of climbing out. This breaks our intuition. We are used to movement being travel through space, but here, space itself moves, dragging you along with it, like a wood chip in a stormy stream. That is why a black hole is not just a prison with very thick walls. There are no walls. You can look outside. You can see the stars. Light from the universe still falls on you, but you cannot send a signal back. No radio signal, no scream, no laser beam can overcome the oncoming flow of space. Your tomorrow is now in the center of the hole. This is the most frightening part of Einstein's geometry. In the ordinary world, you can choose where to go: north, south, west, or east. You can return to yesterday's location, but you cannot return to yesterday's time. time always drags you forward, into the future. You cannot stop aging. You cannot cancel the next second. Inside the event horizon, something incredible happens. Space and time switch roles. The direction to the center of the whole, to the singularity, ceases to be just a direction in space. It becomes your future. Try not to fall into the center of a black hole, while inside the horizon, is the same as trying not to step into tomorrow. It is not difficult. It does not require great effort. It is simply impossible. The geometry has twisted so that all roads, all paths, all rays of light lead only to one point. No matter how you turn the steering wheel, no matter where you aim the rocket, you will fly toward the center. Moreover, the faster you try to run, the faster you will reach the end. By turning on the engines, you only hasten your demise. It is the perfect trap. It does not hold you with chains. It simply curves reality, so the exit ceases to exist as a direction. There is no side of the world where you can fly to get out. The exit remains in the past. And in the past, as we know, one cannot live. But if the story ends quickly for the one who fell inside, for those watching from the outside, a completely different magic begins. The magic of an optical illusion. After all, if space falls, what happens to time? We are approaching the strangest paradox of the event horizon. A paradox that turns a falling astronaut into an eternal ghost. Where does reality end? We are used to everything in this world having an edge. A table has an edge beyond which the floor begins. The ocean has a shore beyond which the land begins. The atmosphere has a boundary beyond which space begins. These boundaries are tangible. If you hit a wall, you feel pain. If you go out into open space without a spacesuit, you feel cold and suffocation. Boundaries warn us. They say, stop. It is dangerous beyond this point. Nature is usually honest with us. It puts fences where we should not go. But a black hole is a liar. The most terrifying feature of this object is that its boundary does not exist. At least, not in the way we understand the word boundary. You will never crash into the surface of a black hole. There is no hard crust, no ocean of magma, nothing you can touch. The event horizon is not a physical object. You cannot knock on it. You cannot take a piece of the horizon and put it in a test tube. It is a ghost. It is a mathematical concept, hanging in the void. It is simply coordinates in space where one rule is replaced by another. And this ghostly nature makes it the most dangerous place in the universe, because you can cross the line of death and not even notice it. Let's go back to our boat on the river, but make the situation even more dramatic. Imagine you are not on a river. Imagine you are in an endless shopping mall, on an escalator going down. You are standing on a step. The escalator moves slowly. You can easily turn around and run up against the movement of the step. You are faster than the mechanism. You go up to the floor above, to the exit to the light. You are free. But this escalator is special. The lower it goes, the faster the steps begin to run. At first, it is unnoticeable. Then you realize you have to walk quickly just to stay in place. Then you have to run. And then comes the critical moment. The steps under your feet are rushing down at the speed of the fastest sprinter on the planet. If you are that sprinter, and you are running up with all your might, you find yourself in a strange situation. Your legs are blurring, your heart is pounding, you are giving 100%. But relative to the handrail, relative to the observer on the upper floor, you are frozen. You are hanging in one point of space. You are on the horizon. The step in front of you is salvation, but it moves away from you at exactly the speed you reach for it. The step behind you is the abyss, and it waits for you to get tired. In physics, this contest is called escape velocity. It is the price you must pay to gravity to leave Earth, A rocket must accelerate to 11 kilometers per second. It is fast, but it is possible. Our engineers know how to build such engines. To fly away from Jupiter, you need 60 kilometers per second. It is incredibly difficult, but theoretically solvable. But a black hole raises the stakes to the absolute limit. As you fall toward the center, the gravitational grip strengthens exponentially. The required speed for escape grows 100,000 kilometers per second, 200,000, 290,000, and finally, you reach an invisible sphere where the escape velocity becomes equal to 300,000 kilometers per second. This is the speed of light. It is not just a big number. It is Einstein's brick wall. It is a law that states there is nothing in the universe that could move faster. Not a rocket, not a particle, not information, not even a thought. The speed of light is the cosmic speed limit for the transmission of cause and effect. And here the trap snaps shut. If to return home you need to move faster than light, and moving faster than light is impossible, then returning home is impossible. It sounds like a simple logic puzzle, but let's think about the horror of this conclusion. We are used to crises that can be resolved. If you get lost in the forest, you can find a road. If your ship is sinking, you can send an SOS signal. If you run out of oxygen, there is a chance rescuers will make it in time. In the ordinary world, hope dies last, but on the event horizon, hope dies first. The very moment you cross this line, the very concept of salvation becomes a physical absurdity. It is like trying to draw a square circle. It is like trying to remember an event that has not happened yet. The laws of the universe simply do not provide an exit option. And the most terrible thing about this crisis is that it is one-sided. Imagine an astronaut falling into a supermassive black hole. Let's call him Tom. Tom is an experienced pilot. He knows physics. He knows he is approaching the point of no return. But because the black hole is huge, the tidal forces at the horizon are weak. Tom is not torn apart. He is not crushed. He looks at the instruments. He looks out the window. He crosses the event horizon, and nothing happens. No siren sounds. No red light flashes. The sky does not change color. The instruments do not go crazy. Tom feels fine. He sees his hands. He sees the stars overhead. He can wiggle his fingers. He can record a video message for his family. Everything is fine, he says into the camera. I passed the horizon. Systems are normal. I will try to turn on the engines and return. Tom does not know that he is already dead. I mean, he is biologically alive. His heart is beating. His brain is working. He is making plans for the evening. But for the rest of the universe, Tom no longer exists. His video message will never be sent. The radio waves carrying his voice fly out of the ship's antenna at the speed of light, but the space under the ship falls down faster than the speed of light. His cry for help flying toward Earth is actually falling into the center of the hole along with him. He is like a man shouting against a hurricane wind that carries the sound back into his throat. This is the true nature of the event horizon. It is not a wall that kills you upon impact. It is a wall of silence. It is the boundary separating events that can be seen from events that have disappeared from history forever. You can live beyond the horizon for a few more hours, maybe days. If the hole is large enough, you can write memoirs, discover new laws of physics, unravel the mysteries of creation, but you will never, under any circumstances, be able to share this knowledge with a single living soul outside. You have become the owner of the greatest secret in the universe, but the price for this knowledge is absolute, eternal loneliness. You are cut off from causality. You have fallen out of the time of the rest of humanity. You still exist, but you are no longer part of us. But why is it this way? Why does space behave so cruelly? Why can you not simply turn around? The fact is that beyond this line, something even stranger happens than just falling very fast. The very meaning of the words forward and backward changes. The geometry of space inside a black hole twists in such a way that the path out disappears, not physically, but logically. It is hard to imagine, but let us try to see it with our own eyes. Imagine that your future is not time. Imagine that your future is a place on a map. So, our astronaut Tom has crossed the line. He is alive. His ship is intact. He turns it 180 degrees, points the nose toward the distant stars he can still see behind him, and hits the gas. In any other place in the universe, this would work. The engines would push the ship forward. The distance to the center would begin to increase, and Tom would be saved. But here, something happens that feels like a nightmare. Tom sees that the distance to the center is not increasing. He increases thrust, burns tons of fuel. The indicators show monstrous acceleration. But with every meter he thinks he is flying away from the center, he is actually getting closer to it. How is this possible? Did the engines break? Did someone swap the cardinal directions? No. Something much more fundamental has happened. Inside the event horizon, the very concept of direction has changed its meaning. To understand Tom's tragedy, let's look at our own lives. Right now, sitting in this room or in front of a screen, you possess complete freedom in space. You can stand up and go left. You can go right. You can jump up or sit down. Space for you is an open map where you can walk in any direction, but you have no freedom in time. You cannot go to yesterday. You cannot stop the moment of now, and you cannot jump straight to next year. Time is a cruel jailer. It drags you only one way, from the past to the future, whether you want it or not. Second by second, you are moving toward your tomorrow. You cannot turn around and walk back into childhood. This is the law of our world. Freedom in space, prison in time, but inside a black hole. Einstein predicted an insane flip. When gravity becomes infinitely strong, it breaks the coordinate axes. Space and time switch places. The moment Tom crossed the horizon, the radial distance to the center, what he considered the depth of the pit, ceased to be space. It became time, and the center of the black hole, that mysterious singularity, ceased to be a point in the center of the sphere. It ceased to be a place. It became an event. It became the future. Think about that. The singularity is not a place where the bottom of the pit is located. The singularity is next Tuesday. The singularity is the end of this week. Now answer this. Can you dodge next Tuesday? You can fly a rocket to the left. You can fly to the right. You can do pirouettes. But whatever you do, Tuesday will come. You cannot run from the arrival of tomorrow. This is why Tom is doomed. His attempt to fly away from the center of the hole is equivalent to our attempt not to age. Wherever he points the nose of the ship, all roads lead to the same time, to the moment of the final collapse. To Tom, space inside the horizon looks as if it closes in on itself. If he looks left, he sees darkness leading to the center. If he looks right, he sees the same darkness. Even if he looks back, trying to find the exit, the geometry of light rays is curved so that there too, at the end of the tunnel, the center awaits him. The center is everywhere, because the future is everywhere. And here arises the cruelest irony of physics. In ordinary life, if you are late or want to make it somewhere in time, you hurry, you run faster, you step on the gas. Tom does the same. He panics. He engages the afterburners. He tries to outrun the inevitable, but in the curved world of time, this works in reverse. According to the theory of relativity, the faster you move in space, the slower time flows for you. But inside the hole, movement toward the edge is an attempt to slow down the arrival of the finale. However, calculations show a terrifying result. The more actively you resist, the more powerfully your engines work, the faster you bring about your end. Any resistance, any energy spent on the struggle, only shortens your path along the geodesic line. The longest you can live inside a black hole is to relax and do nothing. Just fall. Enjoy the last moments of free fall. As soon as you start fighting, you kill yourself faster. You run to meet Tuesday with the speed of a sprinter. A black hole is the only place in the universe where fighting for life mathematically guarantees a quicker death. This is the crisis. A complete collapse of intuition. A complete collapse of the human experience of survival. We are creatures used to fighting. Our evolution taught us fight or flight. If you are cornered, break through. If you are drowning, row. But here, these instincts are traitors. Tom, our astronaut, might be a hero. He might be the bravest man in history. But geometry is ruthless to bravery. His fate was written the moment he crossed the line. Now he is just a clock, counting down to 0. And while Tom rushes to his finale inside, something completely different is happening outside. We left his partner outside, at a safe distance. Let's call her Sarah. She watches his ship through a telescope. She waits. Logically, she should see Tom's ship dive into the darkness and disappear, like a stone thrown into a well. Splash, and it's gone. But a black hole is a great illusionist. It knows how to play with time, not only inside but also outside. What Sarah sees contradicts everything Tom feels. For Tom, the fall takes minutes. But for Sarah, his fall will never end. She will see the ship begin to break, moving slower and slower, as if getting stuck in invisible syrup. She will watch him for an hour, a day, a year. The ship will crawl toward the event horizon, but will never cross it. Why? Because a black hole is not just a trap of space. It is a time machine that has jammed. We have to understand why for one observer, everything is already over, while for another, the tragedy is frozen forever, turning into a motionless snapshot at the edge of eternity. We are entering the time paradox zone. Let's go back to Sarah. She is in a safe orbit, thousands of miles from the event horizon. She sits in the pilot's chair, watching telemetry screens, and looking through a powerful telescope. She is waiting for the moment when Tom's ship disappears. She knows Tom has already crossed the line. Her computer calculated it. By all laws of logic, his ship should have already dissolved into darkness. But what Sarah sees makes her question her own sanity. Tom's ship does not disappear. Instead of diving into the abyss, it starts behaving as if it has hit invisible resin. It slows down. It hangs over the edge of the precipice. Sarah sees Tom raise his hand to wave goodbye to her. But this movement, it becomes agonizingly slow. His hand rises. 1 second, 2 seconds, a full minute. It freezes in mid-gesture. Sarah checks the instruments. Did Tom turn on the braking thrusters? Did he change his mind and hover over the abyss? No, the engines are firing at full power, pushing him inward. But for Sarah, time on his ship has broken. This is the moment we encounter Einstein's most dizzying discovery. We are used to thinking of time as a universal metronome. We think a second is a second in New York, on Mars, and in Andromeda. We think there is a single now for the entire universe, but a black hole proves no single now exists. Gravity does not just pull matter, it pulls time. It stretches it like a rubber band. The closer you are to the source of gravity, the slower your clock ticks relative to those far away. Even on Earth, your feet age slightly slower than your head because they are closer to the planet's core. This difference is negligible, billionths of a nanosecond, but at the edge of a black hole, this difference becomes infinite. For Tom, falling inward, everything is normal. His wristwatch ticks as usual. Tick-tock, tick-tock. His heart beats at a rhythm of 60 beats per minute. He crosses the horizon, rushes toward the singularity, and dies. The whole process takes him, say, 5 minutes. But for Sarah, watching from afar, Tom's 5-minute stretch into eternity. Imagine Tom's life is a movie recorded on a videotape. While he was flying toward the hole, the movie played at normal speed. But as he approached the horizon, someone started turning the playback speed knob back. First half speed, then 1/10 speed, then 1/1,000,000th speed. Every subsequent second of Tom's life takes years of Sarah's time. She will see him approach the horizon, but she will never see him cross it. This sounds like mysticism, but it has a strict physical explanation. We see the world thanks to light. For Sarah to see Tom, light must reflect off his ship, fly up out of the gravitational well, and hit Sarah's telescope. But gravity is greedy. It does not want to let the light go. Imagine Tom throwing balls to Sarah. While he is high up, he throws them easily, but the deeper he descends, the harder it is for the ball to fly up. The ball loses energy, overcoming the pull. It slows down. Light behaves similarly. Photons flying out from Tom must climb a vertical wall of gravity. They lose energy, and loss of energy for light means a change of color. That is why Tom's image does not just slow down, it begins to fade. Sarah will see the white hull of the ship turn yellow. Then it becomes orange, then deep red. The light gets tired, climbing out of the pit. The wavelength stretches. This phenomenon is called gravitational redshift, and finally, the limit arrives. Light emitted by Tom, right from the edge of the event horizon, tries to break out, but gravity pulls it back with the same force. This light freezes. It cannot fly away, but it does not fall back either. It hangs on the boundary forever. To Sarah, it looks like the creation of a ghost. The last image of Tom, the moment he was a millimeter from the point of no return, is imprinted on the sky. He turns red, dims, becomes an almost invisible infrared spot, but he never disappears completely. A black hole works like a monstrous cosmic camera that takes a final snapshot of its victim and keeps it on its surface until the end of time. In the history of astronomy, there was a period when these objects were not yet called black holes. Russian physicists called them frozen stars, and this name is perhaps even more accurate, because for us, the outside observers, everything that has ever fallen into a black hole has not disappeared. It is frozen on its surface. Rocks, asteroids, gas clouds, unlucky astronauts, all of them, from our point of view, cover the sphere of the event horizon like flies trapped in amber. We see their history put on eternal pause, and so we come to a paradox that blows the mind. Two contradictory realities exist simultaneously. Reality 1, through Tom's eyes. I crossed the horizon. I saw darkness. I fell into the center. I died. My story ended a long time ago. Reality 2, through Sarah's eyes. Tom is alive. He is right here in front of me. I see him. He is just stuck. He never crossed the horizon. He hangs there right now, 1,000 years later. Which of them is right? Common sense tells us that only one is right. Either Tom is dead, or he is hanging on the horizon. One cannot be dead and visible at the same time, but the universe tells us, you are both right. This is the twist. This is the fracture of reality. Time is not a straight line. It is a personal experience. For Tom, time has ended. For the universe outside, Tom's time has stretched into an infinite asymptote. He has become part of the black hole's landscape. He has become information smeared across the horizon. Imagine the horror Sarah would feel if she did not know physics. She would think she could save him. He is just hanging there, she would scream. He is barely moving. Let's lower a cable. Let's hook him and pull him out. She would spend years sending rescue pods to this frozen red ghost, but any rescuer approaching the frozen Tom would discover a terrible truth. As soon as the rescuer flies up to the place where the ghost hangs, he finds nothing there. He simply flies through the void and starts falling himself. Because frozen Tom is an optical illusion. It is a mirage created by delayed light. The real Tom has long since turned into spaghetti. In the center of the singularity, we see only his echo, his light shadow, which gravity slowly, drop by drop, squeezes out into our universe. This teaches us humility. We are used to trusting our eyes. Seeing is believing. But here on the threshold of non-existence, eyes are the worst witness. What we see is a lie. What we feel is an illusion. The only truth is hidden where light does not return from. But if time is capable of playing such tricks, if it can stop and stretch, the question arises, what happens to space itself inside this time trap? If from the outside we see a frozen shell, what does the one who actually ended up inside see? It turns out that inside this pause, another secret is hidden. A secret that concerns the very structure of our universe. We are approaching the moment when the black hole ceases to be just a destroyer and hints to us that it might be a creator. But let us return to Tom. We left him falling into darkness, while for the external world, he turned into a motionless red ghost. If outside, time slows to a complete stop, then what happens inside? What does Tom see? If he looks back, over his shoulder, at the universe he left behind, logic suggests a mirror effect. If Sarah sees how Tom's time slows down, then Tom must see how Sarah's time speeds up. And this is perhaps the most breathtaking and terrifying spectacle physics has to offer. Imagine you are sitting in a dark room and looking at a brightly lit window. This window is your event horizon, through which you have just flown. You are falling toward the center. You have only a few minutes or seconds before tidal forces tear you into atoms. But in these last seconds of your life, outside in the big world, millions of years are passing. You will see the history of the future. The stars above your head, which used to be calm points, will begin to move. They will dance. They will begin to rotate at a frantic speed, merging into luminous streaks. You will see stars being born, living their billions of years, and dying in a single instant, exploding like fireworks. The entire evolution of the galaxy will play out before you on fast forward. The light from all these events, the light from the future of the universe falls on you simultaneously. Outside, light reddened and faded, but inside it turns blue and intensifies. Physicists call this violet shift. The energy of light concentrates in the final moments before the end. It is not darkness that will crash down on you. A blinding, hard light of all future time will crash down on you. The entire history of creation, compressed into one blinding flash, will hit you in the back. This is the last irony of the black hole. Dying in total darkness, you will see more light than anyone who has ever lived before you. You will see the end of times, but this light is the last thing you will see, because ahead of you waits the singularity. We often use this word, but we rarely think about what it means. We imagine some kind of ball in the center, a dense rock, fragments of planets compressed into a pile, but general relativity tells us something much stranger. The singularity is not a thing. It is not an object. It is the moment when time ends. Recall how we said that, inside the hole, space and time swap places. The distance to the center becomes your future. So, the singularity is not a point in space where you will crash. It is a moment in time when you cease to be. It is like the edge of an old map, where medieval cartographers wrote, "Here be dragons," and drew a precipice. Only here it is not the land that breaks off. The very tomorrow breaks off. For Tom, the singularity is the absolute finale of his personal timeline. After this point, there is no future, no events, no causes and effects. Imagine a book. You read page after page. This is your life. You turn the pages, days, years, and suddenly you reach the last page. You read the last word, and after that, only white paper, the cover. The singularity is the back cover of the book of your reality. You cannot read what happens next, because next does not exist. The geometry of the page has ended, and this is exactly where the time trap slams shut for good. In our ordinary life, we are accustomed to the fact that matter is indestructible. You can burn a chair, but the atoms will remain. They will become ash, smoke, heat. You can break a cup, but the shards will not go anywhere. We believe in the law of conservation. We believe that the past determines the future, that if we have ash, we can, theoretically, find out what the chair was like. Information about what an object was is preserved in the universe forever. This is the foundation of all quantum physics. Quantum mechanics swears information never dies, but a black hole looks at these laws and laughs. When Tom reaches the singularity, his body, his ship, his atoms, his memories, his genetic code, all of this is compressed into a point of infinite density and disappears from the reality we know. His timeline snaps. For the external observer, he is frozen on the horizon like a ghost, but physically, he has gone into nothing. This creates a conflict that has kept physicists awake for 50 years. If a black hole evaporates over time, as Stephen Hawking predicted, and disappears, taking all the mass with it, then where does all the information about what fell into it go? Where did Tom go? If he turned into thermal Hawking radiation, then this radiation is chaotic. It contains no record of Tom's DNA. It contains no blueprints of his ship. If we burn an encyclopedia, we can theoretically collect the smoke and restore the text. But if we throw an encyclopedia into a black hole, and then the hole evaporates, the text will disappear without a trace. It means that the past can be erased. It means that history is not eternal. At this moment, the black hole ceases to be just a monster that eats matter. It becomes something much more dangerous to our understanding of the world. It becomes a cosmic eraser. Imagine that you are writing memoirs on a computer. You write them your whole life. And suddenly the hard drive does not just break, it disappears without leaving a single byte of data. Your life never happened. That is what the singularity does. It severs the link of times. This is a dead end. This is a crisis of physics. Either Einstein was wrong, and there is no singularity, or quantum mechanics is wrong, and information can disappear. Two of the greatest pillars of science have butted heads in the center of this darkness, and no one wants to yield. But what if we are looking at this the wrong way? What if information does not disappear? What if it is preserved, but not inside? In the next chapter, we will have to rethink everything we know about space. We will return to that frozen ghost on the horizon. Remember Sarah? Remember she saw Tom smeared over the surface of the sphere? What if this is not an illusion? What if, in reality, Tom did not fall inside? What if he became part of the shell? We are approaching the craziest idea in modern science. The idea that says our world is not what it seems. That three-dimensional reality is just a hologram painted on a distant event horizon. The black hole is preparing to reveal its most important secret to us, the secret that our universe might be flat. What is a human being? If we discard poetry and philosophy, if we look at it through the eyes of cold physics, then astronaut Tom is not a personality, not a soul, and not a set of memories. He is a set of particles. He is an incredibly complex, ordered heap of carbon, hydrogen, oxygen, and nitrogen atoms. But atoms in themselves are worth nothing. A carbon atom in Einstein's brain is no different from a carbon atom in a lump of coal. It is not the material that has value, it is the order. How exactly these atoms are connected to each other. Physicists call this order information. Information is the most sacred concept in modern science. It is the currency that pays for the existence of reality. Quantum mechanics, the science describing the foundation of our world, is built on one cast iron rule. Information never disappears. You can change the shape of a thing. You can break it, melt it, evaporate it, but you can never delete the data about what it was before. The universe is a giant accountant who keeps strict records of every particle since the moment of the Big Bang. Not a single line in this ledger can be erased. Let's test this rule for strength. Imagine you are holding a thick encyclopedia. It records thousands of years of history, biographies of kings, maps of continents, formulas for medicines. It is a huge amount of information. Now imagine you throw this book into a fireplace. You watch the fire devour the pages. The paper turns black, curls up, and crumbles into dust. Smoke flies up the chimney. Within a few minutes, only a handful of grey ash remains of humanity's knowledge. It seems to you that the information is destroyed. You can no longer read these articles. For you, as an ordinary observer, history is erased. But a quantum physicist will tell you, you are mistaken. The book is still here. If we had the technology of gods, if we could collect every molecule of smoke that flew out of the chimney, every particle of ash, every photon of light emitted by the fire, and upload it all into a supercomputer, then, knowing the laws of physics, we could run the process backward. We could calculate exactly how every atom lay in the paper before the fire touched it. We could restore the text. Learning is not destruction, it is encryption. Fire simply takes ordered text and turns it into a chaotic cipher. But the key to this cipher is not lost. It is stored in the smoke and ash. In our universe, the law of reversibility works. The past is rigidly connected to the future. If you know the present in all details, you can reconstruct the past. You never lose the trail. That is what we thought, until we looked closer at the black hole. In the 1970s, Stephen Hawking made a discovery that shook the scientific world. He proved that black holes are not eternal. They do not just sit in the void. They slowly, very slowly evaporate. They radiate a faint thermal glow into space. We now call this Hawking radiation. Losing energy through this radiation, the black hole loses mass. It gets thinner, it shrinks, and eventually, after trillions of years, it must disappear completely. Poof, and it is gone. And here the nightmare arises. Let's go back to our encyclopedia. Only now we do not throw it into a fireplace. We throw it into a black hole. The book crosses the event horizon. It falls inside. The information about kings and maps is now locked in a dungeon. But it still exists, right? It is inside. But then, we wait. We wait billions of years. The black hole begins to evaporate. It turns into Hawking radiation. And here is the main question. What does this radiation consist of? Does it carry information about the book? Hawking performed calculations and came to a horrifying conclusion. Hawking radiation is just thermal noise. It is absolutely chaotic. It is the same for all black holes. It does not matter what you threw inside, an encyclopedia, a piece of gold, or a dead cat. What flies back out, as radiation, contains no traces of what fell in. This is not smoke from a fire in which a book is encrypted. It is just a random set of numbers. And so, the black hole has evaporated completely. It has disappeared. Along with it, our encyclopedia has disappeared too. The atoms of the book turned into faceless heat. The connection is broken. The key to the cipher is not just lost, it is destroyed. Even if you collect all the radiation down to the last photon, you will never restore the text. The past is erased. This phenomenon was named the information paradox. It may seem to you that this is a problem only for theorists. What difference does it make if a book disappeared or not? But for physics, this is a catastrophe. It is the blue screen of death for our entire science. Imagine you are watching a detective movie. You are closely following the plot, collecting clues, and suddenly, in the middle of the movie, the film is cut, and then white noise is shown. You did not just fail to learn the ending. The movie itself lost its meaning. If clues can disappear without a trace, then investigation is impossible. If black holes can destroy information, it means we cannot trust the laws of physics. Because the laws of physics are equations of prediction. Knowing the state of the system now, we predict the state then. But if there is a hole in the equation through which data leaks, prediction is impossible. At this point, two titans collided, two pillars on which our world stands. On the left is Albert Einstein's general theory of relativity. It says, space is smooth, gravity curves it. If you fell inside, you are gone forever, but you exist inside. On the right is quantum mechanics. It says the world consists of particles. Information is sacred. Nothing can disappear without a trace. If something enters, it must exit. Usually, these two theories do not talk to each other. Einstein rules the world of huge stars. Quantum mechanics rules the world of tiny atoms. They divided the territory and live in peace. But in a black hole, a huge star is compressed to the size of a tiny atom. In a black hole, these two theories are forced to meet face to face, and they start screaming at each other. Einstein says, the information fell inside, the hole disappeared, therefore the information is destroyed. Deal with it. Quantum mechanics screams back, that is impossible. If information is destroyed, then my entire existence is a lie. Then the past is unreal. Then chaos has defeated order. I forbid this. One of them must yield. One of the greats is wrong. Either Einstein was wrong in his understanding of gravity, or the foundations of the quantum world, upon which all our computers and lasers are built, contain a fatal error. This dispute split the scientific community for decades. It was a real war. Leonard Susskind versus Stephen Hawking. A battle for the preservation of reality. Because if Hawking is right, and black holes really work like a cosmic eraser, then all our history, all our memories are not a solid foundation, but writing on the sand before the tide. At any moment, a wave of gravity can wash away a piece of the past, and we won't even notice that it was there. This is a frightening prospect, a universe that forgets itself. But physicists could not accept defeat. They looked for a loophole, they looked for a way to save the book from the fire, and, as often happens in science, the answer was found where no one expected it. What if we have been looking in the wrong place all this time? What if the book did not burn inside? What if it never fell inside at all? What if what we consider the volume of a black hole is an illusion, and all information is stored not inside but on the surface? We are approaching the strangest, most psychedelic idea in modern cosmology. An idea that could turn our entire universe into a painted picture. To save the past from destruction, physicists had to make the wildest logical jump in the history of science. They had to assume that the 3D world is a fiction. The key to the solution was found by a young Israeli physicist named Jacob Bekenstein. While everyone was arguing about what happens inside a black hole, he looked at what happens outside, at the event horizon itself. Let us conduct a thought experiment. Imagine you are packing a suitcase. You want to pack as many things as possible into it. How do you estimate the capacity of the suitcase? You look at its volume. The deeper the suitcase, the more sweaters, books, and souvenirs will fit into it. This is intuitively clear. The amount of information you can hide in a box depends on the volume of that box. This is how our world works. If you want to build a library that holds twice as many books, you must double the size of the building. You add space to add information. But Wittgenstein, looking at black hole formulas, noticed something strange. When a black hole swallows information, for example, when a massive book falls into it, its horizon grows. The sphere becomes slightly larger, but how much larger? Mathematics showed an astounding result. The capacity of a black hole's hard drive does not depend on how much space it has inside. It depends on how much space it has on the surface. Information is not piled up in a heap in the center, like laundry in a basket. It is smeared on the walls. Imagine a can of soup. Usually, we are interested in the soup inside the volume. The label on the can simply describes the taste. But in the case of a black hole, it is the exact opposite. The soup falls inside and disappears for us forever. But all the information about every ingredient, about every molecule of this soup, remains recorded on the paper label outside. The event horizon is not just a point of no return. It is a giant screen. It is the densest library in the universe. Every electron, every photon, every person who has ever fallen into a black hole has left their fingerprint on this sphere. Data is not lost. It simply transitioned from a three-dimensional state to a two-dimensional one. This discovery led to the birth of a theory that today dominates theoretical physics. It is called the Holographic Principle. You have all seen holograms. There is a small shiny sticker on your credit card. If you turn it in the light, you will see a volumetric image of a bird or a globe. It seems to you that the image has depth. But if you run your finger over the card, you will feel that it is absolutely flat. Depth is an illusion. All information about the 3D bird is encoded on 2D plastic, using a complex pattern of strokes. Physicists Leonard Susskind and Gerard Hust realized that a black hole is that credit card. Remember our astronaut Tom? Remember the paradox where Sarah saw him frozen on the horizon, while Tom felt he was falling inside? The holographic principle reconciles them. It says Tom really fell inside and died. But all the information that made Tom who he was copied and remained on the horizon. All his complexity, all his atoms were scanned and recorded on the shell of the sphere in the form of bits, tiny pixels of space the size of a Planck length. This means the book did not burn. The text of the book was rewritten in microscopic font on the cover of the hole. And when the hole begins to evaporate, Hawking radiation is not random. It reads this data from the surface. It takes information from the horizon and carries it back into the universe. The text returns. The past is saved. The laws of physics stood their ground, but the price we paid for this salvation turned out to be exorbitantly high. Because if this principle is true for a black hole, why should it not be true for everything else? Look around. Look at the walls of your room. Look at the sky in the window. Look at your hands. You feel volume. You feel that the space around you is deep. You can reach out and touch the screen. But what if this feeling is the same deception as the bird on the credit card? The mathematics of the holographic principle is not limited to black holes. It suggests that any volume of space can be described by information on its boundary. If we take our entire universe, all this huge space with billions of galaxies, and imagine it as a giant ball, then all information about us, about our history, about our thoughts, might be recorded somewhere out there, on the distant edge of the cosmos, on the cosmic horizon. This sounds like the script of the movie, The Matrix. But this is spoken not by science fiction writers, but by the equations of string theory. Perhaps you and I are not solid bodies moving in the void. Perhaps we are projections. We are shadows dancing in the center of the room. But the real movie is playing on the walls. Our reality is a 3D cinema that is broadcast from a flat screen at the edge of the universe, and black holes are not mistakes of nature. They are simply places where the projector works too brightly. These are places where we see the pixels of our world, places where the screen comes right up to us. Think about how much this changes everything. For thousands of years, we looked into the sky and sought secrets there. In the depths, we built telescopes to look further. We thought the essence of things was hidden inside them. We dissected frogs, split atoms, hoping to find the truth in the core of matter. But the event horizon whispers to us, "You are looking in the wrong place. The essence is not in the depth. The essence is on the surface." The most important thing happens on the edge. It is there on the thin film of the boundary that the code is written, which forces us to live, love, die, and ask questions. A black hole has ceased to be a grave of matter. It has turned into a keeper. It is the most reliable safe in the universe. Stars explode and fade. Planets crumble into dust. Civilizations disappear. But what fell onto the horizon remains there forever, recorded in the eternal code of gravity. And if this is so, if our universe really is a hologram, then the last, most disturbing question arises. Any hologram, any projection, must have a source. There must be a projector. If we are a reflection, then what is the original? We have reached the finale of our journey. We started by fearing falling into a pit, and we ended by doubting the reality of the very ground beneath our feet. One last step remains. A step toward understanding what place these strange, frightening objects occupy in the big picture of creation. Why did the universe allow their existence at all? Why does it need these holes in the fabric of reality? Maybe they are not holes. Maybe they are doors. Throughout this journey, we have looked at black holes with apprehension. We called them monsters, traps, information killers, cosmic erasers. We treated them as errors in the perfect code of creation. It seemed to us that the universe should be harmonious and understandable. And these dark spots are a kind of cancerous tumor on the body of space, where the laws of physics break and go mad. But what if we are wrong? What if we are judging a book by a typo, not noticing that this typo is repeated on every page? Let's tear ourselves away from telescopes for a minute and look around. Look at nature here on Earth. Nature rarely creates something for no reason. Everything has a function. Hurricanes distribute heat. Forest fires clear the soil for new shoots. Predators maintain the health of the population. In nature, there is no pure evil, only mechanisms. When astronomers began counting black holes, they were shocked. We used to think they were rare anomalies. Now we know there are billions of them. In the center of our Milky Way galaxy sits the giant black hole Sagittarius A. In the center of Andromeda, another one. In the center of galaxy M87, a monster. It seems that every decent galaxy has this darkness in its heart. This is not an accident. This is a pattern. This is an architectural plan. It is impossible to build a galaxy without a black hole, just as it is impossible to build a house without a foundation. They are the anchors that hold stellar islands together. They are the conductors of the gravitational orchestra. But perhaps their role is even grander. Let's ask a strange question. Why would the universe build places from which you cannot exit? Why create zones of absolute isolation? Imagine you are a goldfish living in a beautiful, large aquarium. You have everything, Algae, stones, food that falls from above. You swim, explore your world. It seems to you that your world is huge. But sooner or later you swim up to an invisible barrier, to the glass. You see that there is something behind the glass. Some vague shadows, light, movement. But you cannot get there. You cannot touch that world. Your universe is limited by water and glass. For the fish, the aquarium is the entire reality. It does not know that this aquarium stands in a room, the room in a house, the house in a city. It does not know that its world is an artificial environment, created inside something larger. We humans love to think we are free. We look at the stars and say, space is infinite, but physics puts us in our place. We also live in an aquarium. Our walls are not made of glass. They are made of the speed of light and time. We can see galaxies that are 13 billion light years away, but we will never, under any circumstances, be able to reach them. Space between us expands faster than light. This is our horizon. This is the wall of our aquarium. We are locked in the observable universe. Just as a prisoner is locked in a cell, we can look out the window, but we cannot leave. And this feeling of confinement, this feeling that we live inside a bubble, leads to a frightening thought. Look at the definition of a black hole again. What is it? First, it is a region of space separated from the rest of the world by an event horizon. Second, it has its own laws inside. Third, nothing can exit from it. Fourth, inside it lies a huge mass of energy. And now look at the definition of our universe. First, it is a region of space limited by the cosmological horizon. Second, it has its own laws inside. Third, we cannot go beyond its limits. Fourth, inside it lies a huge mass of energy. Doesn't it seem to you that these lists are suspiciously similar? What if a black hole is not death? What if it is birth? Remember the moment when a star collapses. Matter falls inward, compresses, heats up to incredible temperatures, density grows to infinity, and then, boom, singularity. And now remember how our universe began. Scientists call it the Big Bang. But what was at the moment of the Big Bang? All matter was compressed into a single point. Density was infinite. Temperature was exorbitant. And then, boom, the point began to expand, creating space and time. Mathematically, the Big Bang is a singularity, exactly the same singularity as the one in the center of a black hole. Only one works as an input and the other as an output. This leads us to one of the most dizzying hypotheses in science, developed by physicist Lee Smolin. The hypothesis of cosmological natural selection. Imagine that a black hole is not the end of the road. Imagine that when matter falls into a singularity, it does not disappear into nowhere. It tears the fabric of space-time, like a heavy stone tears the bottom of a rubber bag. And there, on the other side, this tear blows out into a new bubble. For the external observer, for Sarah looking at the hole from the outside, the star simply went out and disappeared. But for the one inside this tear, a miracle happens. Space begins to expand rapidly. Energy is born. The first stars light up. It looks like the Big Bang. Perhaps every time a black hole is born in our universe, somewhere on the other side, a new baby universe is born. Perhaps our universe is not a unique, lonely creation. Perhaps we are simply the interior of a huge black hole that exists in some other even more gigantic parent universe. This thought changes everything. It removes fear. We are used to fearing the dark. We thought a black hole was a predator, but maybe it is not a predator. Maybe it is a womb. Maybe this is the way the cosmos reproduces. Just as flowers scatter seeds, just as fish spawn, so universes create black holes to give life to new realities. This explains why there are so many of them. Why would nature create billions of dead ends? Nature does not create dead ends. It creates offspring. And if this is true, then you and I are inhabitants of a very cozy, very large, but still locked cage. We live inside someone else's event horizon. Our sky, our stars, our history. All of this is happening inside a collapsed star from another dimension. We are the fish in the aquarium, and we have just begun to guess that the glass is not the end of the world. The glass is simply the boundary of our bubble. But this theory leads us to an even deeper question. If universes evolve, if they pass on their laws of physics by inheritance through black holes, then why is our universe exactly the way it is? Why is gravity exactly strong enough to allow stars to exist? Why can carbon atoms connect into complex DNA chains? Why are we here to ask these questions at all? It turns out that the trap we live in is perfectly tuned for life, and this is not an accident. This is the final part of the pattern. If we accept this idea, the idea that our universe is the child of another universe, born inside a black hole, then many mysteries that have tormented us for centuries suddenly find frighteningly simple answers. Look at the physics of our world. It seems suspiciously perfect. If gravity were just a little bit weaker, stars would never have ignited. Gas would simply float in the void as a cold mist. If gravity were just a little bit stronger, all stars would have burned out in millions of years, not having time to give life to planets. If the carbon atom were slightly less stable, life would not exist. Scientists call this fine-tuning. It seems that someone sat at the control panel of reality and carefully tweaked the adjustment knobs to create ideal conditions for us. This forces many to believe in a higher intelligence or in incredible luck. But the theory of cosmological selection offers a third option, the option of evolution. Imagine a universe that does not know how to create black holes. It has bad laws of physics. Stars do not collapse. Space does not tear. Such a universe is sterile. It lives, dies, and leaves no offspring. Its genetic line is interrupted. Now imagine a universe whose laws are perfectly sharpened for creating stars. These stars live, die, and collapse into black holes. Each black hole gives birth to a new daughter universe that inherits the mother's laws. Such a universe is fertile. It has billions of children, and these children also create stars and black holes. Soon, the entire multiverse is filled with exactly these kinds of universes. Universes that know how to create black holes. And so we look at our world. There are billions of galaxies in it. In each galaxy, there are millions of black holes. Our world is a perfect factory for the production of singularities. We live here not because we are special. We live here because we are a byproduct of this process. To create a black hole, a massive star is needed. To create a star, hydrogen, gravity, and time are needed. And the exact same ingredients, hydrogen, gravity, and time are needed to create you and me. We are not the goal of creation. We are the sawdust on the floor of the workshop, where the universe builds its main machines, black holes. We are made of stardust, but this dust was not intended for us. It was intended to one day fall into the abyss and become the seed of a new reality. This may sound insulting. No one wants to feel like a byproduct. But look at this from the other side. We are the only creatures who can understand this. We are the only part of the universe that can approach the edge of the aquarium, press its nose against the glass of the event horizon, and guess what is happening outside. And this brings us back to the feeling of the trap. At the beginning of this film, we spoke of the event horizon rule as something ominous. Exit is physically prohibited. It sounded like a sentence, like a prison. But let us think about what a prison is, and what a fortress is. Their walls are the same. The difference is only whether you want to get out, or afraid of what is outside. If our universe is indeed inside a black hole, then the event horizon is not a prison bar. It is a shield. It is a membrane that separates our fragile reality from what is located in the parent universe. Maybe out there, chaos reigns. Maybe energies rage there that would instantly destroy our matter. Maybe laws of physics incompatible with life operate there. The event horizon protects us. It guarantees that nothing from there will enter here to destroy our order, and it guarantees that we will not fall out into that chaos. We develop inside a protected shell, like a chick in an egg. The shell seems to it an insurmountable boundary, the end of the world, but it is this boundary that allows it to exist. Perhaps all the black holes we see in the sky are also eggs. We look at them and see darkness, but perhaps inside each of them, right now, someone is looking at their stars and thinking, how huge and infinite is my world? They think their universe arose from a big bang. They do not know that their beginning of time was just the moment of a star's collapse in our galaxy. It is an infinite Russian doll. Universes inside universes, inside universes. A grand fractal extending to infinity, both up and down. And the connecting link, the door between these floors, is that very point we fear so much. The point where time stops. The point where space tears. The event horizon is not the end of the story. It is simply the bookbinding separating one volume from another. We are prisoners. Yes, we will never leave this bubble. We will never know what color the sky is in the parent universe. Our ships will never overcome the speed of light to break through the wall. But now, looking at this wall, we should feel not fear, but awe. Because this wall is proof that we are part of something alive, part of a system that grows, breathes, and evolves. The black hole has taught us the main lesson: nothing disappears without a trace. Even if you fall inside, your information will be preserved. Even if a star dies, it will birth a new universe. Death is not the switching off of the light. Death is simply a passage through the horizon. We are used to dividing the world into here and there, into life and death, into light and darkness. But the geometry of space-time shows us that these boundaries are conditional. They exist only in our heads. For the universe, there is no inside and outside. There is only a single, infinitely complex surface that curves, dances, and wraps into knots, creating the illusion of matter, the illusion of time, and the illusion of ourselves. We stand on the edge of understanding. We have taken apart the trap mechanism. We have understood how it works. One last question remains, a question we are afraid to ask aloud. If we know how this mechanism works, if we understand the rules of the game, will we ever be able to become the ones who build these traps ourselves? Or perhaps we have already started. We have come a long way. We started with a simple wall, with barbed wire, with the idea that there are boundaries that cannot be crossed. We drifted down the river of space, fell into the waterfall of time, saw reality turn inside out, and discovered that our universe might be nothing more than a hologram at the edge of someone else's abyss. Now, standing here at the end of this journey, we must admit one thing, a thing that is rarely heard in scientific papers, but which lies at the heart of any discovery. We must admit our humility. Despite all our telescopes, despite the equations of Einstein and Hawking, despite supercomputers modeling the collapse of stars, the event horizon remains what it was named from the very beginning, a limit. It is the boundary of our knowledge. We can guess what happens beyond it. We can write formulas that work on paper, but we do not have a single witness. Throughout the history of the cosmos, trillions of particles, rocks, planets, and perhaps living beings have crossed this line, and not a single atom has returned to confirm our theories. Nature keeps its secrets with fanatical devotion. Roger Penrose, one of the greatest physicists, called this the cosmic censorship principle. The universe seems to intentionally hide its naked singularities from us. It hides its most intimate mechanisms, its points of failure, behind an impenetrable black curtain. Why? Maybe we are simply not ready to see what is inside. Maybe if we saw a naked singularity, if we saw that very source code in which reality is written, our minds simply would not withstand the sight. We are used to assuming that knowledge is light, that the more we shine a flashlight into the darkness, the clearer the world becomes. But black holes remind us that darkness is not just the absence of light. Darkness is an independent force. It is a vault. It is a safe code to which we may never crack. And yet, we do not stop looking. There is a strange irrational pull to this. Why does the abyss beckon us so? Why, when we see an image of a black hole, do we feel not only horror, but also a strange delight? Probably because we feel a kinship. We ourselves are made of the same matter that craves to fall. The memory of gravity is sewn into every atom of our bodies. We are children of stars who want to return home, to the ultimate peace at the center of everything. But while we are here, on this side of the horizon, we have a task. We have deciphered part of the code. We realize that space is a river. We realize that time is an illusion. We realize that the death of information is perhaps the birth of a new world. What is next? If we know the rules of the game, will we ever be able to become players instead of pawns? Scientists are already talking about the possibility of creating artificial black holes. Tiny ones, the size of a proton, in particle accelerators. We dream of engines that will warp space, just as dying stars do. We dream of wormholes, tunnels through this forbidden horizon that will allow us to cheat the speed of light. This sounds like science fiction, but 100 years ago, flying to the moon was science fiction. 200 years ago, a voice transmitted over wires was magic. The only thing that distinguishes magic from science is understanding the rules, and the black hole is our main teacher. It is the strictest examiner. It stands there, in the center of the galaxy, and waits silently. It waits for us to grow up, for us to stop fearing the dark, and start reading what is written in it. Maybe the event horizon is not a wall. Maybe it is a door that is currently locked because we have not yet found the key, or because we ourselves are still too big, too crude, too attached to our 3 dimensions to crawl through the keyhole. But we are knocking. We send our thoughts, our formulas, our dreams to this edge, and we hear an echo. If space is capable of bending, can time ever break? If this was only the beginning of understanding what awaits us in the next chapter, if we really live inside a giant cosmic nesting doll, will we ever be able to peek at the level above? There are no answers, not yet. There is only gravity, there is only time flowing forward, and there is the silence of a great, beautiful and frightening mystery. Look at the night sky tonight. Find the darkest patch between the stars, and remember, emptiness does not exist. There, in the darkness, someone is looking back at you, and perhaps, right now, at the edge of someone's distant universe, on the event horizon, a new star is lighting up.